those of you playing at home, sorry you're not with us. When we talk about something having infinitely many solutions, that means literally anything we plug in there, 800,400,762 could be a solution. 7 could be a solution. 0.000004 could be a solution. Literally anything we plug in would be a solution. So to get your brain around that, let's look at this table. Now when I'm choosing values for a variable, and this will make more sense when we get into geometry, I like to choose a couple negatives, I like to use 0, and I like to use a couple positives. So if we try -2, -1, 0, 1, and 2, those are a good list of 5 options for values to plug in. So now if we think about this with -2 plugged in, you could, if you wanted to, first distribute in these expressions to make it a little easier. If I distribute my 3 into my parentheses, what will I get?
Oh.
Nate?
12s plus 24.
12s plus 24. Don't forget your s. And if I distribute my 2 in, change colors, what do I get?
24 plus 12.
So if I plug in a -2, put a -2 in for s, 12 times -2 would give me, Shahib, -24, then plus 24, Shahib, 0. -24 plus a positive 24 brings us back to 0. If I plug it in over here, I get the same thing.
Oh my goodness. Is it the same?
If I plug in -1, I'm going to get a -12 plus 24, which would give me 12. And if I do it over here, I get the same thing. If I plug in 0, I just get 24 for both of them. If I plug in 1,
You get 36.
I get 36. If I plug in 2,
48.
I get 48. So what we can say is if I set up 3 times 4s plus 8 equal to 2 times 12 plus 6s, watch what happens as I try to solve this. Imagine if this was your equation. I distribute on both sides. I get 12s plus 24, like you guys already told me, equals 24 plus 12s. I get rid of my constants and try to group them. But when I do that, they're gone from both sides. I then get 12s equals 12s. If I have the same thing on both sides, does it matter what I plug in for s? No, this is going to be equal no matter what. So this is where I see infinitely many solutions. By the way, some people have issues spelling infinitely. It's infinitely. Infinitely many solutions. No?
Couldn't you just put the little X sideways?
Kind of. It's not really an X. It's like an 8 sideways, actually.
That's what
Yeah. So you could put like infinite solutions if you want to not have to write the word. But I wanted to make sure we knew how to spell infinitely, infinitely, not finite, not countable, too many to name. Now we want to be able to quickly identify whether I'm going to have no solutions, 1 solution, or all of my numbers possible. And how we do that is to analyze our equation when we start
What's
solving.
that you say? You're looking for the way to one solution to a linear equation in one variable? Well, the truth is you may not be able to get there from here. You see,
Has anyone ever watched The Dukes of Hazzard?
My dad.
This is spoofing on the Dukes of Hazzard.
Sometimes there's one solution to a linear equation in one variable, but there are times when a linear equation in one variable can have no solution, or infinitely many solutions.
Well, you see here, the Duke boys have got themselves into some trouble.
A linear equation in one variable.
Okay, not going to let it play anymore. I just like the Dukes of Hazzard. It's a good show. If you've never watched it, it's pretty sweet. Watch some episodes. It's good classic TV where like nobody ever actually dies and there's always like cops looking like goofs. So linear equation in one variable. What? No, okay. This sounds really fancy schmancy. A linear equation in one variable. All that means is we're only using one type of variable, one letter, and if it's linear, means it will travel in a straight line. Anyone know other types of graphs? Non-linear graphs? There's a graph that on your XY axis would look like this. A parabola. There's also graphs that would look like this. It's not a parabola because it does not go back up.
Hyperbole? No. That's something else.
This is a graph modeling regression. Infinite regression. You continually get smaller and smaller and smaller and smaller and smaller. And there's also graphs that start and just get infinitely bigger. And, well, no, slope talks about what the steepness at a given point is. So all of our graphs that we're working with will either be a straight line with a slope, a straight line vertical, a straight line horizontal, and that's it. We're going to be working with straight lines. Either a straight line going up with a slope, a straight line going down with a slope, horizontal or vertical. Those are my options for linear graphs. So we start looking at an equation. Say we've got 57.9 minus 98.2y equals 303.4. We know how to solve this. We group our constants together first, and since my variable starts on the left side, I keep it on the left side. So get rid of your 57.9 by subtracting. Then I want to get rid of the multiplication, so I divide by the coefficient, and I get my solution point. Now, that's not a point. It's just a y value. Right? How would I find an x value there?
Why are you subtracting the 57.9?
Because it's positive. Even though, thank you for that question, I was hoping somebody would ask that. Even though it's held together with subtraction, that belongs to the 98.2. This number is a positive number, so to get rid of it, I have to subtract. That's where these, you have to really analyze what's going on. Because if I turned that around, it'd be negative 98.2y plus 57.9. It's a positive value. So finding a value for your variable tells you there's one solution point. We could then use that y value to figure out what the x value is, and that would help us graph it. But all we care here is because I find a value, it's got one solution. Anyone think of a situation where there could be no solutions? There's not an answer to it?
It's not a real number.
So, here's our no solution. You know that an equation has no solution. I want you to highlight, underline, circle, star, whatever you can, when, as you solve for it, you get a false statement. When you get something that is not true, math never lies to you. This is why I fell in love with math. It is true. It has an answer. It's black or white. It's right or wrong. There is one correct answer, or two correct answers, or however many answers there are. We know that we can find them. If something doesn't make sense, it doesn't make sense. It is not correct. So as we're solving this equation, we distribute the 3 out. We work to get my, too far. We work to get my variable terms together, so I subtract 6g from both sides. But when I do, I get an expression that tells me that 12 is equal to 9. Is 12 equal to 9?
No.
No, never can 12 be equal to 9. I don't care what base system you're counting, and I don't care what planet you're on. 12 is not equal to 9. Since that's false, as soon as we see a contradiction, we know the equation has no solution. As soon as we see a contradiction, the equation has no solution. And actually, we could have recognized that right here. Because 6g is a shared value, you cannot have something plus 12 and have that equal to something, the same something, plus 9. Olivia?
We don't have the, when you solve for the variable, you get a false statement.
You have, were there weren't actually. Let me see what's on here.
So we have no solution.
Yeah, so right here, I'll pull up your notes and show you where I'm looking for you to write this at. One none infinitely many. Right here. So system more than one none. So right below no solution, write false statement or contradiction, or so false statement's already written right here for you. So you might not write it again. You might highlight it, circle, start something that, like, when you see something that's not true. The other way that we say this, that we use a lot in math, is contradiction. We found a contradiction. That cannot be true. So that's what tells me there's no solution, is that there is a contradiction. We all good now? We found that on our notes. So it might help you to draw lines to separate these. So I want you to put on your detective hat. Get out your eyeglass if you need. Don't smoke a pipe. We now know that that is not good. Sherlock Holmes, that's what I'm trying to allude to. We are going to work through and identify whether these have one, none, or infinitely many solutions based off the first point possible. The first place that we can see it. Oh, come on. Let me clear. So if a contradiction gives us no solutions, what's our rule for identifying infinitely many? Right?
Just like the infinite sign and solution.
That's how we can write it. When we see a true statement that is identical on both sides. So on your notes, if you are trying to notate that, you could say identical sides, or however you would paraphrase that. You have identical left and right sides, because I could identify that way up here. I have a 7 on both sides. I have a 4p on both sides. I could stop right there and say, hey, we're going to have infinitely many solutions. I have the exact same thing on the left and the right side. Cool? All right, so, come on. There was a lot of setup, but it was worth it. So, when 4 equals 9, how many solutions? None. It's a lie. The cake is a lie.
It's a lie.
That's a game that I actually like. I can't play it because I don't have the right game system at home. But
What game?
Portal.
Oh, it's such a fun game.
If x is equal to 2/5, right?
Is it one solution?
One solution. X has a value. That's the solution. Zach, what about 2/10 equal to 0.02? Is that true?
Wait, no.
No, because this is 200ths.
Oh, yeah.
This is 2/10. It's a lie. It has no solution.
Why you always lying?
Pranav, what about 2j plus 7 equals 2j plus 7?
Infinite many.
Infinitely many. The left and the right sides are identical. I cannot call in the whole class. Jackson, what about 1/2 equals 5/10? Jackson left the room. Karen. Infinitely many, because I have identical left and right sides when I simplify them. Noah, What about 3h equals 12?
1.
That'll have 1 because there is an answer there. So please make sure you have examples of these written down so that you can refer back to them. What do you notice about our no solution? What does it not have? Pranav?
It doesn't have a correct answer.
Okay, it's a lie. It doesn't have a correct answer. There's no variables. When you get a no solution situation, you should either have no variables or no constants. Well, most of what we're working with. When it gets really complicated, you might have both, but you should be able to manipulate it so that one set cancels out. Either your variables cancel out or your constants cancel out. Because if you have 3j equals 4j, you really actually can find a solution. You can divide and get 0 or subtract and get 0. Like, we can figure out how to manipulate. We'll see examples. It'll make more sense.
Which category would it be put in if it said x equals y?
That is a graph, actually. So that has the graph of x equals y. When x is 1, y is 1. When x is 2, y is 2. When x is 3, y is 3. When x is 4, y is 4. So
Or like
as long as they are always equal and it can be true, it have infinitely many. Assuming that we can't, like, that there's no rules that get in the way of that. All right. So when you see 1/2 equal to 2/3, Miss Tyler, what do you think?
like
How many solutions? 1, none, or infinitely many? None. Is 1/2 equal to 2/3? No. There are no solutions. And we either write none or no solutions. Do not write 0 because you might think that 0 is your solution. Because sometimes 0 is your answer. Oh, the empty set? You mean that? Yes. So you can put the empty set symbol to represent that there is not an answer that exists. Good question. So I want you guys to try to write a linear equation in one variable. All that means is using a constant, using a coefficient, and using a variable that has no solution. No solution. So remember, to make no solution, it has to contradict. It has to be a lie. Then write a linear equation in one variable that has infinitely many. So you want it to end up being identical on both sides. So they can end up canceling out. That can end up being your answer, but it would have to first have variables involved. So actually, I want to pick on Shahib a little bit because I like what he had. Shahib had 1 equals, did you use point or was that a comma? Yeah. So 1 equals 3.14, and I said that's good, that's a contradiction. However, since it asked us to use one variable, we have to start with something that has a variable. So what could we do to give it a variable? Yeah, just add in a variable. So we could say 1 plus 2h equals 3.14 plus 2h, which will then cancel out, contradict, and have no solution. What about infinitely many? Peyton?
I put 17w plus 6 equals 6 plus 6.
That what you said? Yeah. That would work. I love it when people get creative. So another one that we could have would be something like 3 times 2z plus 4 will equal 2 times 3z plus 6, because these would be 6z on both sides, and the distribution would give us 12 on both sides. So we get a little creative with some distribution so that we can use some different numbers. But if you want to be easy to yourself, just make the left side equal the right side. Brown?
So could we do 4x times 2 equals 2, the quantity of 2x plus 2x?
Yep. Because you'll end up with 8x on both sides. So lots of options for what we could do for infinitely many. Just make your left side equal your right side. So when we see the equation, math please wait, there we go. 4 plus w plus 5w equals 3 times the quantity, 2w plus 1.6. Shoot, by the way, anyone have their mastery still out? Number 2 on the mastery was a throwaway. I realized the problem was not written very well. A lot of us missed it. You got it right, actually. That's what I was looking for. What I was looking for on number 2 was 5 times the quantity x plus 8, and that's why I had those commas in there. Huh? Yeah, exactly. Commas group the words, just like parentheses group the mathematical. So that's what I was looking for, but a lot of you had 5x plus 8 equals whatever it was. I made it a throwaway problem. So even if I marked like minus 1/2, it didn't matter. I just decided when I went back, I decided that wasn't. That's why if I haven't explained this, I grade everybody's front page, then I grade everybody's second page, then I normally like wait, like either till the morning or whatever. I go back, look at them, like your whole test together, and grade it, whether it's progressing mastery, what it is. And so I don't really have preferential grading. When I'm grading, I don't care who you are when I'm grading. I care who you are when I go back and look at what you did. So what do I need to do here, James, to start trying to figure out if I have one, none, or infinitely many solutions? And if I have one, I got to find what the solution is. I got to distribute, and actually I have to simplify on both sides. So when I look at the left side, my w and my 5w can combine. So I can make this 4 plus 6w. When I distribute, I have 6w. What's 1.6 times 3? Well, what's 3 times 1? 3. 3 times 0.6, 6, 12, 18, or actually 1.8. So I get 4.8. Can anyone tell right now how many solutions we're going to have? Karen? Why? The 6w, I like what you said, but this is really like, I think how your brain figured it out. The 6w is shared. Now what Karen said was when I subtract, what were you going to subtract? The 6w. Those will cancel each other out, which will leave me with just 4 equal to 4.8, which is not true. When I have 4 equal to 4.8, this is a contradiction, which means there are no solutions. Or you can put the empty set. Questions?
No.
Thanks for your enthusiastic answer. Try this on your own. I want you to only work the problem as far as you have to. So if you figure out there's infinitely many solutions, stop working and write infinitely many. If you figure out that there's none, stop working and write none. If you realize that there's one, you do have to continue and work the whole problem.
I thought we were doing the
Oh, Peyton, you were next too. Peyton, what'd you do first? You distributed and you got.
4n minus 9
Okay, so we get minus 8, then we minus 1 more.
equals. Well, and then I subtracted 5n.
Yep, you did that.
4n plus 9. And I realized that there's no solution because of 4n.
If the 4n's are shared, they're the same, but the minus 9 and the plus 9 are not the same. No solution. Now, Peyton, what else did you notice?
Below it, there's the answer.
Below it, the entire solution process is shown to you right here. This is all on your notes. Your whole solution for the got it is on the notes printed. So it's when we get to this point right here, put an arrow and put a star to that. That tells me when I see the 4n is shared and the minus 9, the 4n shared and the plus 9, that difference in addition versus subtraction, bless you, is how I realize there's no solution. Now, if I keep going, yeah, I get down to here, but I don't need to. I don't need to keep going once I see the contradiction. Making sense?
Making dollars.
Yeah. I wish. When we were, this is when math gets fun. When I worked at Scout Camp for the summer, worked at Muskingum Valley Scout Reservation, we made, and this was a while ago, so I don't know what they make now, we made $500 for the summer. That was from about noon on Sunday, like whenever we got out there after church, to about noon on Saturday. We pretty much worked 6 days out of the week. And we would work from essentially sun up to sundown, well, later than sundown. We calculated how much money we were making per hour. It was like cents. Because we took, there's like 8 weeks of camp, there's 6 days a week that we're working, how many hours? We did all the math, and it was pretty bad. We also did the math for when I was a lifeguard. We had 13 lifeguards on duty. And if there was anybody swimming, we had to be there clocked in working. It was like a really rainy morning. There were 4 people, I want to say, at the pool, so they paid 4 admissions. But we were paying 13 lifeguards to all sit around the pool. And we calculated how much money we were losing every hour by being open. Because it was rainy and like dreary. We're like, let's just go home. Let's just close. And the boss wouldn't let us. We're like, we're losing this much money. We did it on the whiteboard in the lounge. It was pretty funny. I digress. On this problem, when we distribute, what are we going to end up with? Noah? 1x minus 0.5 equals x minus 1/2. Noah, what do you realize there? There are infinitely many solutions because it's identical. I've got an x on both sides. I've got a negative half on both sides, or a minus half. It's identical. If you can draw an 8, you can draw an infinity. Just turn your paper sideways. If you take an 8 and turn it side, I can't rotate with this one, I don't think. It is your infinity symbol, essentially. Or you can draw the Jesus fish. Wait.
Yeah, I got taught how to write that and draw it.
I'm not as good at that.
Jesus fish. You have a mustache?
Yes. Don't judge my fish who hit puberty too early.
It's his fish.
He had a growth spurt. What do we get here? Who wants to help me? Jackson?
Infinite many solutions because 5r minus 3r equals 2r. And so if you just subtract that last r, then it's r. R equals r.
Now here is why PEMDAS tells you in multiplication division and in addition subtraction, we have to work left to right. If Jackson did this in the wrong order, and did 3r minus 2r first, or sorry, 3r minus r, he would get 2r. 5 minus 2r would give you 3r, which is not how this works. You have to work left to right, doing the 5 minus the 3r first to get 2r, then minus the r to get just r. R equals r gives me infinitely many. The new pirate movie. You guys can't see it. It's rated R.
Oh, the Matrix is rated R.
Yes, okay, the pirate one's a joke.
Oh, now I get it.
If nobody laughs, I'll just use my button. All right, at what point in this solution should we recognize how many solutions there are? Nate?
Combining like terms.
When we combine like terms, because I see I have a 4p on both sides and a 7 on both sides, this step right here tells me there's infinitely many. No, we have form.
Oh, yeah. Well, then I'm try that.
No, I think Mr. Kabila decided that science is going to be on Monday.
Science is so hard.
Wow,
You get like a 2.
Was there a video that I was supposed to show you guys?
Yes, there was a video. you were
Which
supposed to
one?
show us. I have no clue. I just want to watch the video.
Oh, the Mythbusters.
Video.